Hello everyone. Today we will discuss flow of liquids. When liquid is flowing, when liquid is moving from one place to another place, तो then there we will apply Bernoulli theorem. Bernoulli theorem के लिए पहले हमको जानना होगा कि जो हम लिक्विड लेने जा रहे हैं उसकी दो कंडीशंस होनी चाहिए. वो होना चाहिए हमारा जो है Bernoulli theorem के अकॉर्डिंग कि आपका when an incompressible and non-viscous liquid flowing, okay, तो then what will happen, then flowing fluid में गैस भी हो सकता है, flows in streamline motion. कंडीशन है कि streamline motion होना चाहिए, not a turbulent motion, zigzag motion from one point to another point. Then at every point, at every point of its path, the total energy per unit volume और per unit mass भी हो सकता है, ये ध्यान रखिएगा. अब यहाँ पे जब एनर्जी की डिस्कशन करने जा रहे हैं तो एनर्जी यहाँ पे तीन तरीके की हो सकती है. टोटल एनर्जी का मतलब यहाँ तीन तरीके की होगी: प्रेशर एनर्जी, काइनेटिक एनर्जी एंड पोटेंशियल एनर्जी. वैसे हम जनरली मैकेनिक्स में काइनेटिक और पोटेंशियल लेते हैं, बट व्हेन फ्लूइड इज फ्लोइंग, fluid means gas or liquid, so then you will consider pressure energy also. So the sum of pressure energy, kinetic energy, potential energy per unit volume will constant. Then here you will see pressure energy per unit volume formula is P, kinetic energy per unit volume is half rho v square, then potential energy per unit volume is rho gh. Keep in your mind, in place of m you will write here both place rho. Rho means density. The sum of these will be equal to constant. It means if anywhere pressure is there, so maybe पोटेंशियल एनर्जी लेस, काइनेटिक एनर्जी मॉडरेट होगी, तो इन तीनों का सम जो होगा लेकिन वो कांस्टेंट होगा. अब इसको हम कैसे समझेंगे, जरा समझने की कोशिश करेंगे स्टूडेंट्स. फर्स्ट सी इन दिस डायग्राम, ओके, हियर वी आर टेकिंग टू नॉन यूनिफॉर्म क्रॉस सेक्शनल एरिया. one we are taking a1, another we are taking a2, okay. हाइट h1 सेंटर से ले रहे हैं h1 और इसकी h2, वेयर h1 इज ग्रेटर देन h2. area of this first part x point पे, that is more than area of this part a2. Then you know equation of continuity, that is the a1 v1 is equal to a2 v2. If area is more, so then velocity will less, so v1 is less than v2. And here you have seen h1 is more than h2, so then pressure will also come here. Pressure will be that it will become p1 will be more than p2. These things you will write four things in the diagrams, then no need to write in the language, okay. Now how will we do here? Learning point is there. We will apply work energy theorem कि whatever we work done, that will be equal to the net increase in energy. Please keep in your mind, earlier we were taking only kinetic energy. That time was height was same, so height was same, so no change was in a potential energy when we were doing in 10th class kinetic energy, work energy theorem. So that time we were not considering that potential energy because the potential energy was same everywhere. But here height is changing, so you know students ki potential energy will change. So here you will consider potential energy as well as kinetic energy. Now how will we do? First we will find work done, that is the net work done. We will find net increase in kinetic energy, then we will equate, then we will get this formula, okay. Now for this x point, what will we do here? Whatever be water is going, water or liquid, whatever be fluid is there going, so let we will consider here in a unit time, or we can say 1 second. So 1 second force will come, this will become, that is the your p1 v1 a1, okay. Then at y point the same p2 a2 y2. So how much work done, that we will take difference here, so that will become p1 a1 v1 p2 a2 v2. Now from the equation of continuity I told you a1 v1 is equal to velocity upon time, and velocity sorry, volume upon time, and volume, that time we are taking 1 second, so we can write only volume per second, or m by rho into t we can write also, okay. But t we are taking 1 second, so we will not write t. Then that time here I want to explain, it is the reason I write here v by t. So in case of here 1 second, it will come m by rho. Now here velocity is less, here velocity is more. It means kinetic energy at this point will be greater than to this. So how much change in kinetic energy increasing? That is half mv2 square minus v1 square. Now potential energy is more here to here, so here potential energy is decreasing. How much decreasing in potential energy? That you will get mg h1 minus h2. Now for from work energy theorem, that you know net work done is equal to the net increase. कितना हुआ, एक बार तो कह रहे हैं बढ़ रही है, ये घट रही है, तो टोटल कितना इंक्रीज हुआ? That we can write in this way, half m1 v2 minus v1 square minus mg h1 minus h2. Okay, then what will we do here? हम यहाँ से m जो है इसको कॉमन निकाल सकते हैं और रो को इधर ले आए, ऐसे भी कर सकते हैं। तो p1 माइनस p2 इज इक्वल टू रो हाफ रो v2 माइनस v1 स्क्वायर माइनस जी h1 माइनस h2। अब इसमें 1 1 2 2 सब नंबर आ रहे हैं और इधर p1 माइनस p2 आ रहा है स्टूडेंट्स। सो व्हाट विल वी डू? p1 वाली टर्म्स हम एक साथ ले लेंगे, p1 प्लस हाफ रो p2 वाली एक साथ ले लेंगे, p1 वाली एक साथ ले लेंगे। सो देन व्हाट विल वी गेट? p1 हाफ रो v1 स्क्वायर प्लस रो gh1। सिमिलरली हियर वी विल गेट p2 plus half rho v2 square plus rho gh2. So what is the general? P plus half rho v square rho gh is constant. Okay, so this is the important relation that is the explained by the Bernoulli, which is known as Bernoulli theorem. The sum of pressure energy, kinetic energy and potential energy per unit volume is constant. Okay, अगर हम यहाँ पे जी एच से डिवाइड कर दें तो ये प्रेशर हेड, ये वेलोसिटी हेड और ये आपका एच रह जाएगा। ओके, तो ये इस तरीके से वेलोसिटी हेड, प्रेशर हेड भी न्यूमेरिकल्स में पूछा जा सकता है। So this was your Bernoulli theorem derivation. I hope so you understood. Thank you.